All right, so today I'm doing a lesson on section 3.3, slope of a line and rate of change. So there's already videos in the classroom for 3.1 and 3.2, so you can watch those, and then here we've got 3.3. So 3.3 covers introduction to slope, the slope formula, parallel and perpendicular lines, and then applications of slope, particularly rate of change. So we're going to start with slope. So slope measures the steepness of a line. It's a number that indicates to you how steep a line is. The larger the number, the steeper the line is. So if you have a slope of 10, that is steeper than a line that has a slope of 2. Slopes can be positive or negative. So a positive slope means that your line is increasing or it's going up as you move from left to right. A negative slope means the line is going down when you move left to right. So positive means it goes up, negative it goes down. If you are comparing slopes and they have different signs, like you have a positive 10 slope and a negative 10 slope, ignore the sign. Those are actually the same steepness because the number itself is 10. So when you're looking at steepness of a line, you ignore the sign and you just look at the numbers when you're comparing. Now the formula for slope, we've got different forms from it. The one thing that we always use is the letter M. So M represents slope. And I looked into the history of this. Nobody really knows why the letter M is used. It just somehow became convention, and that's what we're using. So M represents slope. And there are multiple ways you can think of it. You can think of it as rise over run, basically how much you're going up or rising. And then run is a horizontal distance. This is also thought of as the change in y over the change in x. Sometimes you'll see it with triangle symbols. Those are actually Greek letters. That is the Greek letter delta. So the little triangle is actually Greek letter, and that just represents change. So that's just literally whoops, it'd help if I spelled change correctly. But that is basically just taking change in y, change in x, and just taking the words change in and making it a symbol. Then we've got y2 minus y1 over x2 minus x1, and that is the actual, like, what it actually means when we say change. So when we say change, we're basically saying the horizontal distance, basically, or the difference between your vertical distance, which is y, and then your horizontal distance, which is x. So that's just basically translating that change into a specific formula that we can use. So the most important part is knowing M, and then to understand this y2 minus y1 over x2 minus x1 part. Now, slope is sometimes called the average rate of change, and average rate of change is used whenever you have something that's not a straight line. So if it's almost a line but not quite, we use the word average to just kind of indicate that it's not a perfect line, but it is basically measuring how much something is changing. So that's basically what slope is, and we're going to start with just using the formula. So I've got two examples here. So the first one, a roof rises 8 feet over a distance of 24 feet. What is the slope? So I always like to draw pictures. So I have a roof, and I have my house. So the rise is always our vertical distance. So our rise is going to be 8. And then that distance of 24 is going to be that horizontal distance. So that is going to be that basically the rise over run. So when we use our formula for slope, we're going to use the rise over run version because that's the information that they're giving us. So they're telling us that it rises 8 feet, and then the distance of 24 feet is the run. Slopes often come out with fractions, and we leave them in fractions. We don't generally convert them to decimals. So notice that this is feet over feet, so your units cancel. So we don't have any units on our answer. So we just have 8 over 24, which we need to reduce. So I can divide both numbers by 8 to reduce that fraction. So when I reduce this, I get 1 over 3. So the slope of the roof is 1/3, and there are no units there because the units canceled out. The second example here is finding the slope of a line that passes through 2 points. We have -5, 4 and -11, 12. So when you're given 2 points, that's where you use the form with the y2 minus y1 over x2 minus x1. So in order to use that, we need to label the points. So when we have ordered pairs, it's always x, y. So the first point, I'm going to label this as x1, y1. So the -5 is x1, 4 is y1. And then the second point is going to be x2 and y2. So those subscripts, the numbers below, are just labels for the first point and the second point. So our formula for slope when you're dealing with ordered pairs is y2 minus y1 over x2 minus x1. And then you need to replace the numbers. So this is going off of what I've labeled. So y2 is 12. So I'm going to replace y2 with 12. And then you subtract y1, which is 4. Then in the denominator, it's x2 minus x1. So I look at what I've labeled. I've got x2, which is -11, minus x1, which is -5. So we're going to be subtracting a negative. So on the top of this fraction, I can do 12 minus 4, which is 8. And then in the denominator, when you're subtracting a negative, that's adding. So I'm going to just write this as -11 plus 5 so that it's more clear. So I have 8, and then we have -11 plus 5, which gives us a -6. So I have a negative slope here, so this means this is going to go down if we drew a line between these 2 points. And we need to reduce this fraction. So I can divide 8 and 6 by 2, so I'm going to reduce this. And whenever we get a negative, we usually just put that in the middle if we have just one negative sign. And then that would give us a -4/3. So the slope of this line is negative, which means if you plotted those 2 points and you connected them, it would go down from left to right. And the actual value for the steepness is 4/3. Are there any questions on either of these two examples? Okay. Now I'm going to take a look at a word problem or an application of slope. So in 1985, the U.S. Postal Service charged 22 cents for first class letters and cards up to 1 ounce. By 2015, the price had increased to 49 cents. And honestly, I don't even know what the price is these days because I never mail anything out. Let X represent the year and Y represent the cost of 1 ounce of first class postage. Find the average rate of change of the cost per year. So when it says average rate of change, that is telling you that you want to find slope. When it tells you cost per year, the word per means divide. So we're going to have cost divided by the years. And the way that slope works, it's always y over x. So your y is going to be the cost and the x is the year. Now they already told us that, but in case they had not told us that, you can figure it out by the fact that they're telling us cost per year. So we have our ordered pair. It's always x comma y. So this is going to be year and cost. So we're going to go back to the beginning. We have 1985. So that is the year. So we have 1985. And then the cost was 22 cents. Then they give us another year, 2015, and that is 49 cents. So I have two ordered pairs here, and I'm going to label them with x1, y1, x2, y2. And I just first point, second point. So this is x1 and y1 for the first ordered pair, and then x2, y2 for the second ordered pair. So now we're going to use the formula for slope because they're telling us we're finding the slope. So I'm going to rewrite this. This is y2 minus y1 over x2 minus x1. So I need to plug in my numbers. So y2 is 49 cents, so that's 0.49. And then y1 is 0.22, 22 cents. So we subtract our y values, and we always have to subtract everything in the same order. So if I take my second point minus the first point, then for the x's, I have to subtract in the same order. So that would be 2015 minus 1985. So I'm going to grab my calculator here so I can do this section. So I get 0.27 over, and then 2015 minus 1985. It'd help if I actually typed in on my calculator. That is 30 years, which my brain apparently still thinks that was only 20 years ago, or clearly not. Now, whenever we have a decimal and a fraction, we convert it to a decimal because we don't have decimals on top of fractions. So we're actually going to divide that out. So you're going to do 2.27 divided by 30. And this comes out to 0.009. Now let's take a look at the units here. So on top, this was dollars, and then in the bottom it was years. So our units here, so this would be dollars per year. So the average rate of change is $0.009 per year. Often with slope, you'll get questions like interpret the value of slope, and basically what does this mean? So we write a sentence. If it says to interpret the value of slope, that is telling you write a sentence. So you would have to say the average price of postage, and I use the word average because it's saying average rate of change. So the average price of postage, and then you say whether we're increasing or decreasing. Because this is positive, we're increasing. So increases, or even better, I'm going to actually rewrite this. Let's start with the price of postage because we can reword these multiple ways. So we'll say the price of postage increases by an average, so that's where I'll put the word average, of, and then we have our dollars, $0.009 per year. So the per is division, so since we divided by year, that's what gives us our units. So slope it tells you the steepness of a line, but it also tells you how much something is changing. So if you have anything in real life where you're having something changing and it's increasing by some amount or decreasing by some amount, and you want to know how much is it increasing over a certain amount of time, so like per year, per month, salaries where you get paid per hour, those are all slopes or rates of change. So anytime you're paid on a salary or paid by an hourly rate, that is a slope. You're actually working with slopes every day and you don't even know it. Are there any questions on this example? Okay. Now, types of slope. So there are different types of slope. I've already talked about positive and negative slope, and there are some pictures here where positive, you can see the shape as you move from left to right, it's going up, and negative slope as it moves from left to right, it's going down. Zero slope. So zero slope is horizontal. So if you have a horizontal line, your slope is 0. So m is equal to 0. And this is because there is no vertical change. So in your slope formula, you would have 0 over some number, and 0 divided by anything is equal to 0. So any horizontal line has a 0 slope. Vertical lines, though, like this one right here, we have a vertical line, that has an undefined slope. So you would literally write undefined. And we get undefined when we are dividing by 0. So this has no horizontal change. And the formula is your vertical change over your horizontal. So you're dividing by 0. And whenever we divide by 0, we get undefined. So your undefined slope is going to be something where you're dividing by 0. So those are always going to be vertical. So just keep in mind that most of the time we get numbers for slope, but we could get 0 or undefined if it's either a horizontal or a vertical line. So those are special cases. So I've got 2 lines here, and we're going to find the slope of both of these. So the top one is a negative slope, and the bottom one is a positive slope. In order to find the slope when you're given the graph, you have to pick 2 points on the line. It doesn't matter which ones you pick, as long as you pick 2 of them. So I always try to pick ones that are easy to read off of the graph. So like I have an ordered pair right there. I try to pick the ones that are on the grid. And then it looks like it crosses the grid right here as well. So it looks like I have -1, 0, and 3, -1 as 2 ordered pairs on this line. So I'm going to label these x1, y1, x2, y2, and then I'm going to use the slope formula. So it's y2 minus y1 over x2 minus x1. So y2 is -1 and y1 is 0, so that's -1 minus 0. x2 is 3. x1 is -1. So -1 minus 0 is -1. 3 minus -1 is the same as 3 plus 1, so that gives us 4. So we get a -1/4 for our slope. And we should get a negative because it's going down. So that's a way to check whether you did it right. If it's going down, it should be negative. Now the second line here, this has a positive slope, and I should get a positive slope. So once again, I want to try to find 2 points that are kind of cross the grid that are going to be easy to work with. And you can pick any points you want, and you will get the same answer. So I could maybe pick these 2 ordered pairs, but there's also one here, it crosses here, so you have a lot of good choices there if you want to pick any of those 4 points. So you can pick any of them. Anything that's on an X or Y axis is really easy. So if I pick our y-intercept, that's 0 or 1, that's that point right there. And then let's say my second point, I'll use that point right there, but it really doesn't matter. So that looks like it's at 1, 3 is our ordered pair. So I said the slope is rise over run. So it's basically, if you're looking at the pattern, you're looking at the grid, we go up 1 or up 2 over 1. So the slope would be 2 over 1. And we'll show you how you get that with the formula. So actually, first I should label my x1s and y1s. So x1, y1, x2, y2. M is equal to y2 minus y1 over x2 minus x1. I always make sure to write the formula so that it helps me remember. So y2 is 3 and y1 is 1. x2 is 1, x1 is 0. So I do my subtraction. 3 minus 1 is 2. 1 minus 0 is 1. So you can see, just like I said, we're going up 2 and then over 1. And you can see that we do that with each of these. We go up 2 over 1. Up, over. Up, over. So you can see between each of these points, it has basically the same vertical and horizontal distance. And that gives you an idea. That's what the slope means, basically. And then when you have something like 2 over 1, you can just divide that. So our slope in this case is 2. And it's positive because we are going up. Are there any questions? Okay. Parallel and perpendicular lines. So lines that are parallel have the same steepness, and they don't intersect at all. They're just going to kind of follow each other, parallel lines. So if they have the same steepness, that means their slopes are equal. So parallel lines, the slope of one, which we could label as M1, is equal to the slope of the other line, M2. Now, if you have lines that are perpendicular, then their slopes multiply to -1. So their slopes are opposite in sign, and they are reciprocals. So there's 2 ways you can think of it. You can think that the slope of one of them is equal to -1 over the second one, or if you multiply the 2 slopes together, they give you -1. If 2 lines are not parallel and they're not perpendicular, then we just say they are neither. We don't have a special name for that. So I've got 2 examples here. A line has a slope of m equals -4. Find the slope of a line that would be perpendicular and parallel. So parallel slopes have the same, parallel lines have the same slope. So this one's easy. It's also going to be -4. This is going to be the same slope. Perpendicular have the opposite sign. So our given slope is negative, so the perpendicular slope is going to be positive. and then you take the reciprocal. The reciprocal of 4 is 1 over 4. So the perpendicular line would have a slope of 1/4 as compared to the other line, which is -4. Now, two lines have slopes of 2/3 and 3/2. Are they parallel, perpendicular, or neither? So we can first check if they're parallel. If they're parallel, their slopes would be equal. So M1 would be equal to M2. So M1 is 2/3 and M2 is 3/2. These are not equal. Let me actually do that in a different color. They're not equal, so that means they are not parallel because they are not the same slope. Next, we will check perpendicular. So the way that I check perpendicular when I'm given two slopes is I do the multiplication test. So I see, do they multiply to -1? So M1 is 2/3, M2 is 3/2. When you multiply across on the left side, 2 times 3 is 6, 3 times 2 is 6. You get 6 over 6, which is 1. And then you have something that is not true because you have 1 equal to 1. So they are not equal. So that means they are not perpendicular. As I multiplied them out, I didn't get -1. Instead, I got +1. So if they're not parallel and they're not perpendicular, then the correct answer is neither. Any questions? Okay, so my last example, which apparently...
Miss Stephanie.
Yes.
What does it mean? I'm sorry, I had walked out when it say no particular. I mean, yeah, it says no perpendicular.
Perpendicular?
Yes, ma'am.
So parallel lines, I'll go here. So if we have parallel lines, I'll draw what those look like. So that would be if you have two lines and they have the same kind of shape, they're going in the same direction. Perpendicular lines form right angles. So if I have one of them going this way, then the other one has to go the opposite direction. So there's basically a right angle in between them. So it's like it's kind of, if you tilt your head, it's kind of going straight. If they're neither parallel or perpendicular, then they cross, but the angles are not going to be the same. They're not going to be even angles. So they're not going to look like either of those two options. So when I say it's not perpendicular, that means that these two lines with those slopes, they're not going to look like either of the pictures with the parallel and the perpendicular. So they're going to cross at some angle, but it's not going to look like the other two where it looks kind of even.
Okay.
There are other questions? Okay, so last one here. Line 1 goes through 0, 0, and -2, 4. Line 2 goes through 1, -5, and -1, -1. Are these lines parallel, perpendicular, or neither? So in order to determine this, we need to figure out the slope. So we need to find the slope for line 1 and the slope for line 2. So I'm going to do these in different colors. So line 1 slope will use M1. So it's y2 minus y1 over x2 minus x1. So I'm going to just take the second point minus the first point. And the y value is the second number in the pair. So that's going to be 4 minus 0. And then you take the x's, so negative 2 minus 0. So that gives us 4 over negative 2, which we can divide. 4 divided by negative 2 is negative 2. So line 1 has a slope of negative 2. Now we need to find the slope for line 2. So I'll do that one in purple, and I'll label that slope M2. And so now I'm going to use the second numbers here. So it's y2 minus y1. So we have negative 1 minus negative 5. And then our x values, we have negative 1 minus 1. So negative 1 minus negative 5 is the same as negative 1 plus 5. That gives us 4. Negative 1 minus 1 is negative 2. And when you divide those, 4 divided by negative 2, that gives you negative 2. Now to determine whether they are parallel, perpendicular, or neither, you look at their slopes. Their slopes here, these are the same. And same slopes mean they are parallel lines. So your answer would be that these are parallel. I'm going to pull up a graphing calculator that might be helpful here. So this is something, this is not Desmos, which I often use. This is actually something called GeoGebra, and it allows you to take ordered pairs and draw lines between them. So let's see, I want this line button here. So I'm just picking line, and then I'm going to use what I had on my slide here. So we're going to use 0, 0, and then the negative 4, comma 2 here. So I'm going to hit line, and then I need to zoom in. 0, 0 is right here, so I'm going to click 0, 0, and then other point was negative 2, 4. So I'm going to go down to negative 2, and then it's at 4, so I'm going to go up to 4. Oops. I want to delete that. That was just wanted to move. There we go. So negative 4. So that's the first line that we were given. So I just connected the 2 points and drew the line. Our second line goes through 1, negative 5, and negative 1, negative 1. So I'm going to graph that one. So 1, negative 5. So I'm going to have to move a bit so I can see that on the graph. 1, negative 5 is down here. And then it was negative 1, negative 1. So that's right. So you can see that they have the same steepness there. They're not crossing. That's what it means to be parallel. So you can see that they're basically going at the same angle here. So those are parallel lines. And that's what we got when we found the slope here. We got the same slope using this formula. Let me graph. Let's see. I don't have the lines here. I can show you one with neither, though, with these slopes. It works better when you have ordered pairs, but I can make it work. So I just need to delete these. So I'm going to just start anywhere. And it said so go back to the second example that we have on this slide, where they had a slope of 2/3 and 3/2. So 2/3 is up 2 over 3. So I'm going to go up 2 and then over 3 to give me my first line. Then I'm going to just pick a random point. Actually, that's a bad point because I want to make it on the grid. So I'm going to just pick a point grid here. And it says the second line and 2 is 3 over 2. So that's up 2 or up 3, right 2, the rise over run. So I'm going to go up 3 and right 2. So these are not parallel lines because you can see that the angles are not the same. They don't go at the same steepness. And they're not perpendicular because they're not forming like a plus sign essentially. So, oops. Keep wanting to move it. So they're not perpendicular because they don't have a plus sign. It forms a really narrow kind of X here, which means that, so that means it's not perpendicular. If, to show you what a perpendicular line looks like, let's see. I know there should be a way to get a perpendicular line. I'll try to get a perpendicular. So something perpendicular, I want to make a line, makes what looks like it's equal. It splits sort of the angle around that point equally. So let's see. So this would be trying to make something that is perpendicular. There we go. So perpendicular, kind of, you can see how around the X is equal on, it makes it into 4 sections that look the same size. So that's what it means to be perpendicular. Versus the not perpendicular where, oops, where it was sort of angled, that we had a smaller angle on 2 of the sides. It was more condensed. Does that help with the perpendicular, the parallel, and the neither? I'm gonna hope it does. So those are the shapes: parallel, perpendicular, and then neither. So that was that's basically everything that is covered in 3.3. Is going through whether lines are parallel, perpendicular, neither, and then being able to find the slope and calculate it based off of these graphs, or based off of if you're given like ordered pairs and they're actually giving you numbers and you're using the formula. Do you guys have any questions for me?
So, Miss Stephanie, that formula, that
Mm-hmm.
X1, X2, and Y1, Y2, that what we use for our discussion questions, right?
Yes.
Okay.
Yes. I love your eyeshadow, by the way. That's fantastic.
Oh. Thank you.
You're welcome. Yeah, so for your discussion, you'd be using this formula, and then you're going to be using what's called point slope form. And I do plan on making an example discussion like on Sunday, during my office hours on Sunday. I'm going to try to make an example, so that if you're not sure how to format it, you can take a look at my example on Sunday.
Okay.
There are other questions? All right. Well, thank you guys for coming. I really appreciate it. And hopefully this will, you know, be helpful when you start going through the discussion and like reading through the material and everything. Definitely recommend watching my other videos in 3.1 and 3.2. So this makes, this kind of fills in some of those gaps after you read those, or watch those. It can fill in any gaps you have. So thank you. And I will try to get this out soon, probably, hopefully within the next hour. I'll send it out to everybody so that you have the emailed copy of the recording. And I will talk to you guys later.
Okay, be careful.
Bye. Yes, everybody stay safe for sure. All right.